Good morning, sir. My name is D. Hemanth from first year BTech CSC. Today, my topic is about working of nuclear power plants. Outline of the presentation. Introduction to energy. What is nuclear energy? Nuclear reactor. Components of a nuclear power plant. Steam generation, coolant system, safety measures and environmental impact. And at last, conclusion. Introduction to nuclear energy. Nuclear energy basics. Nuclear energy is derived from the process of nuclear fission, where the nucleus of an atom is split, releasing a thermodynamic amount of energy. Energy density and efficiency. Nuclear energy has an incredibly high energy density compared to other sources like fossil fuels, low greenhouse gases emission. Unlike fossil fuels, nuclear energy production does not limit greenhouse gases like CO2 during the electricity generation process. What is nuclear energy? Nuclear energy defined. Nuclear energy is the energy that released when the nucleus of an atom split or when atomic nuclei combine. combine. This process generates a thermodynamous amount of heat energy conversion and electricity generation. In nuclear power plant, controlled nuclear reactions produce heat which is used to create steam from water. Nuclear reaction in detail. Nuclear fusion process. Nuclear reactor facilitate controlled nuclear fission where where atoms, typically uranium or plutonium, split into smaller fragments, releasing a significant amount of energy in the form of heat. Safety and containment. Safety measures are paramount in nuclear reactor to prevent accidents and ensure proper functioning. Multiple layers of containment system are in place to mitigate the risk of radiation leaks or core meltdown. Components of nuclear power plant. Reactor core. The, the heart of a nuclear power plant is the reactor core, where controlled nuclear fission takes place. Cooling system. A circular component in the cooling system which prevent reactor from overheating. Sys- Steam generation and generator and turbine. The heat generated in the reactor is transferred to a secondary loop where it heats water to create steam. This steam is directly towards a turbine. Steam generation, heat transfers process. The nuclear reactor produces an immense amount of heat through controlled nuclear fission. Steam turbines, the high pressure steam produces from the heat exchanger is directly towards turbines. Electricity generation. The spinning turbines are con- connected to electrical generators, converting the mechanical energy from the turbine into electrical energy. Coolant system, heat regulation and transfer. The primary purpose of the coolant system is to manage and transfer heat generated within the reactor core. It absorbs heat from the nuclear reactions to prevent overheating of the core. Steam generation. As the coolant absorbs heat from the reactor core, it reaches high temperatures and pressures. This this hot coolant is then directly to a secondary loop where it transfers its heat to separate water sources. safety measurements and environmental impact. Containment systems. Nuclear power plant are equipped with multiple layers of containment system to prevent radiation leaks and ensure safety. Emergency shutdown protocols. Plants are equipped with scram systems they that immediately shut down the nuclear reaction in case of emergency. Strict regulations oversight. Strict regulations are rigorous inspection by nuclear regulator bodies ensure that nuclear power plant adhere to strict safety protocols. Environmental impact. Low greenhouse gases emission. Nuclear power plant generation produces minimal greenhouse gases emission during electricity production, unlike fossil fuels. Conclusion. Low carbon energy sources. Nuclear power plant plays a crucial role in providing a low carbon energy alternative, reliable base load power. Nuclear power plants offer stable and reliable sources of base load electricity. Emergency security and diversi- di- diversification. Diversification of energy sources is essential for energy security. Thank you.